Hi everybody. If you could grab a piece of paper or something that you can write down some notes on. I know this is a little bit weird that you don't have the copy because this is not really in the book, and what is in the book is not done very well. So I've redone some of it, and we won't be using the book for the notes, so I apologize for that. But we will be using the book for the homework just to make it a little bit easier for you. The rest of the year, whether we're in school or not, will feel this way, where every couple weeks we change what we're doing. So it feels a little bit choppy at the end, but it also, in some respects, is a little bit more interesting because we do change up what we're doing rather than just doing the same trig that we were doing for all those months in a row. So real quick, I want to go back over vectors. I know it hasn't been that long since you've done them, but just because it's an important part of what we're doing next, to put a vector in component form, remember you do head minus tail. For some reason I can't get this thing right. There we go. So head minus tail. And so for here, in the vector form is these pointy brackets. We're going to go, the head is obviously what we start with, x minus x, so negative 3 minus 2, and then we do the y's, so negative 4 minus 7. So in vector form, in component form, this vector is negative 5, negative 11. Now this next part right through here is how you write the vector equation of a line. This is a little bit confusing and it doesn't make a lot of sense right now. As we go through this will make a little bit of sense, and if you've makes better sense. And if you've done this in ALEKS, then you'll know for sure, because this is in ALEKS. So if you've done this in ALEKS, this is the same thing. But this basically, and we'll go back through the definition here in a minute, but this is basically what we're going to do. We're going to subtract the two x's, we're going to subtract the two y's, and then that is going to be equal to our parameter times our vector. So basically we take the points and we put this in component form. That's really all it's saying, is basically do what we just did. So in this particular problem, they want us to write a vector equation describing this line going through a point, and it is parallel to this other vector. Well, we don't have 2 points. So remember, when you did this up here, you had to have 2 points, and you can tell the difference because the points are written with rounded brackets. So we don't have 2 points. So we do not have the terminal. So I'm just going to say the terminal is not given. And we know that we have to go head minus tail, or terminal minus initial. So because we don't have the terminal, we're just going to use x and y. So now we're going to do x's, so now we're going to call this just plain old x. Now remember, we're using the point, so now we do x minus 3, and then for the y values, we would have y minus a negative 9, so that's y plus 9. And you set this equal to, according to this definition up here, t, because we don't know, times a1 and a2, which is negative 1, 2. Now, t is your parameter. And a lot of times we use t because t generally stands for time. And a parameter is a way of describing a relationship using some other variable. Like I said, in this case, it should be time. So normally when we have an equation, right, we have here's a point and here's a point. But now basically if we connect these and make this line, the question is going to change. It's going to say, well, where is our object at time equals 5? What is the position at time equals 5? So now we're looking for an xy value based on time. So now we have 3 variables. It sounds a little bit more complicated than it is, and those of you in physics obviously understand position vectors and do some things with that. For those of you going to take calculus next year, this is a big part of calculus. Not necessarily parametric equations, but this whole idea of a position vector. So if we take a look at this next problem here, it says a line, we're going to align through a point, any point, is parallel to this vector, and then of course the vector, sorry, didn't mean to shake your face like that. The vector is written in component form. This is what we need to know. That in order to find the x value, we're going to run through one, you take the x point, and then your parameter times your x value. And then for the y, you take the y point, y sub 1, and with that plus your parameter times the y value. So let me show you what I mean. This is a little bit awkward that it doesn't really fit, sorry. So neighbor says to find the parametric equations of a line parallel to vector B and passing through a point at 4, 3. Make a table of values and graph the line. Now this table is a little bit extreme. There's kind of a lot of values there. I don't know necessarily that we need that many, but let's start by setting this up. So we're going to go back up to that first definition, way back up here at the top, where it says to take, and we're going to write this in component form. So we're going to take our vector. Again, we don't have the terminal, so we're going to do what we just did, except here's our point. It's kind of hidden there. So we're going to have x minus 4, y minus 3, and this equals whatever they tell us. Component form of the vector times your parameter, t, times positive 3, negative 5. So now basically we have to separate this out. That's what this is. In order to find x, you take your x point. This is x sub 1. This is y sub 1. This is a sub 1, and this is a sub 2. So now we're going to say that x minus 4 is equal to, just distribute this, 3t. Now in the formulas up here it says t times your number. You can write t3 if you want. Most people don't like to have the letter first. Let's solve this thing for x just to make this a little bit easier. So we get x equals 3t plus 4. Now for y's, we do the same thing. Y minus 3 is equal to negative 5t. Right, again, we're just taking t times our y value. That's all that says. So now we're going to have y equals, y, oh yeah, sorry, it does equal that, so we're moving this over here. Negative 5t plus 3. Now we have two expressions, one for x and one for y. And you're going to do this based on t. So you plug in the t values, and then you can find your x and y. Now we don't need to do all these points. This is the part that is on Alex. So if you've been skipping over parametric equations, you will need something to write with. You can't necessarily do it completely on the screen on Alex, but if you have a little piece of paper, you can write it down, and it does go pretty fast. So let's do the easy ones. Let's do 0. So again, put the 0 in here for t and in here for t. You're finding x and y separately based on time. So at time equals 0, where is our point? So if we plug a 0 into the x, we get 4. And if we plug a 0 in here, we get 3. So at time equals 0, this object is located at the point 4, 3. Let's plug in a 1. A little bit of arithmetic now. So 3 plus 4, that'll give 7. And negative 5 plus 3, that'll give you negative 2. So now what we're going to do is we're going to graph this thing. We only need really 2 points to graph this line. So let's graph the line. And what you have to pay attention to is the order. So that was our first point, 4, 3. I'm going to do the second point a little bit different. So 7, that's 4, 7, negative 2. So basically the line went this way. So in Alex, what you would then have to do is you would then have to click on the tool. It looks kind of like this in Alex. You have to click on the line, and then it'll draw these arrows showing the direction in which is the motion of this object along that straight line. Again, for those of you who are going to take calculus next year, in calculus, we deal with lines a lot. So it may seem kind of basic or elementary or sort of algebra 1-ish, but it's true. We deal a lot with lines. So a lot of linear equations, writing equations of line, talking about slopes. It's not difficult, but it is something that comes back a lot in calculus. So we're kind of preparing you for that. So for this one, we're going to switch this up a little bit. We're going to write the parametric equations for the line. This is rectangular form. This is point slope intercept form, if you'd rather call it that. But we want us to do this in parametric form. And when you do this, you're going to always start off with x equals t. Every single problem is going to start with x equals t. That's just what you make x. Then you rewrite the equation with t. So you literally just take this x out and make it a t. So the second part would be y equals negative 4t plus 7. Parametric equations are one for each letter. So if you have 5 letters, you would have 5 equations. We have 2 letters, we have an x and a y, and you write each equation based on t. Now for number 4, the first thing we have to do, which you know is a big deal, is solve for y. We always wanted to always solve for y. We want it to be y equals. So let's solve this thing for y real quick. So we get y equals negative 1 minus 9x. If you don't like that positioning of the variables, you can switch it around. So I know a lot of people like to have the x before the intercept. So for this, then we're just going to take out the letter x and put in the letter t. We get y equals, I'll rearrange this here, negative 9t minus 1. And these are your parametric equations. It truly is that simple. Now let's put the two ideas together, some stuff from the front, and then of course writing these equations. So now we don't have the equation. We have something that the equation is parallel to. So write parametric equations for this line passing through a point is parallel to this other line. Well, we don't care so much about this line. We're just using that line for its slope. So we need to solve it for y in order to figure out what the slope is. So negative y is equal to 3 minus 2x. We change all the signs, and this is our slope. So now we know that the slope is 2. We have a point of 1, negative 2. Now we're going to use point slope form. If you've forgotten what point slope form is, it's the best way to write an equation of a line with what we have. So it's y minus your y coordinate equals the slope times the letter x minus your x coordinate. We have a slope, we have one x and one y, so the equation will have an x and a y in it. So let's plug this in here. Y minus negative 2. Our slope is also 2, and x minus 1. Then all we have to do is get this thing solved for y, because that's how we want the parametric equation to be. So we have y plus 2 is equal to 2x minus 2, and y equals, when we subtract a 2 here, we get y equals 2x minus 4. So the parametric equations, x equals t, there it is again, and y equals 2t minus 4. It has to be x equals and y equals. There's lots of ways to write the equation of a line, but for parametric equations, it has to be x equals y equals. So for 6, we're going to write an equation in slope-intercept form based on the parametric equations. This is also in ALEKS. Your first thing you want to do is solve each for t. So basically get t by itself. Then you're going to set the two equations equal to each other. And then you're going to write it in y equals mx plus b form. Because it does say that, slope-intercept form. That's the only reason why you have to do that last step. So for this, we're going to have x equals negative 5 plus 4t. So we get x plus 5 equals 4t. And you don't have to do a lot of simplifying here. When you divide by 4, just leave it like that. It might be easier. X plus 5 over 4 equals t. Now, for the y equation, we have y equals 2 minus 3t. So we get y minus 2 is equal to negative 3t. And when you divide by negative 3, don't go through a bunch of work. Just keep it nice and simple. Y minus 2 over negative 3 equals t. We don't have to worry about simplifying it at that point. Now that they both equal t, you set them equal to each other. So x plus 5 over 4 is equal to y minus 2 over negative 3. And then, of course, you cross multiply. It doesn't matter which direction you go first. I'm going to go this way first. So negative 3 times x plus 5 is equal to 4 times y minus 2. Simplify this a little bit. We get negative 3x minus 15 equals 4y minus 8. Solve this thing for y. So I'm going to add the 8. So negative 3x minus 7 equals 4y. And then, of course, divide by 4. And again, how you want to write it is up to you. In ALEKS, I think when I do it, I kind of don't write it very nicely. And you can probably do the same thing. You don't have to necessarily make it two fractions. You can just go negative 3x minus 7 over 4 equals y. Because none of that reduces. It'd be different if it was like 8/4 or something that could reduce. Now this last one is one we've already done, but just to kind of go back through it, just because now that you have maybe a better idea of how they're connected. This says describe the graph of the parametric equations, and they give you the two parametric equations. It's going to be a line, but basically we want to describe it with, is it a line with a positive slope? Is it a line with a negative slope? So we're just going to give a little bit more detail. I would suggest making your table, just like we did on the front. Now this is, again, like I said, it is in ALEKS. Pick numbers that are easy based on the problem. If there was a 3 in the denominator, I'd pick a 3. We don't have any denominator, so I'm going to pick 0 and, I don't know, let's make it easy, 1. We don't have to make it tricky. So when you plug a 0 in there for x, we get 3. Plug a 0 in there for y, we get negative 1. And you plug in a 1 here, we get 7. And when we plug in a 1 for this one, we get negative 1 plus 2, so we get a positive 1. So I'm going to draw a quick graph just to take a look at what this is. There's our first point, and then of course our second point goes over here. In ALEKS, remember, you'd have to use your line tool and draw your first point, second point. Then you have to click this little key that looks like this with the two arrowheads with the line running through it, so that you would get the arrowheads showing up in the correct order. So this, it did start here and it ended here. So this is the direction it goes in. So basically we could call this a line with a positive slope. Not a super great description, but it's a line. We don't really have much to say about it.